And welcome to day 8, people. Hopefully, if you had a power cut like I did yesterday, you've recovered today. Had some hot showers and all those kinds of things that you miss when you don't have electricity. And it's good to see that there's lots of responses for the survey already so far today. So that's cool, with only, I think, 9 days to go until our exam. So it's good that we're all back on with the program and ready to go. Okay, so I'm going to do part 1 and part 2 this time. Just so that for part 1 we can make it clear that we know how to set out our answers, and then for part 2 to look at this shade area, which is a little bit different from the ones we're doing before. In fact, it's probably a little bit easier than the ones before, but anyway. Cool, so the equation of BC, like the video yesterday, the point B is going to go through the the point B is going through the y-axis, which means that at that point x is 0, and the point C is going through the x-axis, so at that point y is 0. We know that this line BC is a normal to the curve, which means we have to find out what the gradient is at point B and then reciprocate it and change the sign so we get the equation, the gradient of that line. We also need to know what the point B is by finding the intersection between the curve and the y-axis. So why don't we start off by doing that one there. So if we're trying to find out where point B is, we want to find out where the curve cuts the y-axis, and so we know at that point x is 0. So if I'm trying to find the y-intercept, I'm going to put up this equation here, and I'm going to replace x with 0, so 4 times 0. So I get the square root of 1 plus 4 times 0, which is just square root of 1. So that means y is at 1. Okay, so point B is just the point 0, 1. Let's find the gradient at that point. So this time I'm going to write it as 1 plus 4x all to the power of a half, because it's a square root sign, and that'll make it easier for us to differentiate. So when I do dy dx, you get half, 1 plus 4x all to the power of negative a half, and that is a composite function, so I've got to make sure I check the inside of the brackets. In this case here, when I differentiate 1 plus 4x, I'm going to get 4, so I need to multiply all of that by 4. So if I tidy that up, that becomes 2, 1 plus 4x all to the power of negative a half. I know what x is at that point. X is 0, so to get the gradient at that point, I substitute in x is 0. Okay, so 1 plus 4 times 0 to the power of negative a half. So when I go through and substitute that, I get 1 to the power of negative a half, which is still just 1, times 2. So the gradient at that point is 2 for the curve. We want the normal, which is perpendicular. So our gradient that we're going to use is actually going to be negative a half. Okay, so just wrap that up. That part there was all about finding the point B, and this part here was all about finding the finding the gradient of this line. And so the last thing to do is actually to find the equation itself. So if we use the formula m times x minus x1 equals y minus y1, then we got negative a half x minus 0 equals y minus 1. They haven't told us to rearrange that at all, so actually you can leave it like that, although it would be a little bit strange to leave the x minus 0 there. So you'd probably just write negative half x equals y minus 1. Okay, and on to part 2. So the area of the shade region is always really good to analyse the situation first. So this one here doesn't involve like the ones we've done before. The ones we've done before, we've had something like, shall I draw it again? We've had a weird area that we couldn't get directly, so we had to do subtraction to find it out. So for example, we might have had like a curve like that, and at the same time we might have had a line like that, and we wanted this area here. And so the only way to get that area was to work out the area of the triangle and the area of the whole area under the curve, and then subtract it to get that one there. This is a different situation. What we have here is we have one part of an area which is an area under a curve, and then we have another part of an area which is an area under a line. So in this case here, actually what we're going to do is do the two parts separately and then just add them together to get the total area. Okay, so that was this is a different approach. So you may have tried doing something like this, okay, but it's not the same scenario. Cool, so that just involves us having to set up two equations. What it does mean is that we do need to know what A is and what C is, and we haven't worked those out yet. So let's do that first. Okay, so A is going to be where the curve hits the x-axis, so that means y is 0 at that point there. So let's go with our equation here. So our equation for the curve is 1 plus 4x all under the square root sign. We want that to equal 0. So if we square both sides, we get 1 plus 4x equals 0. Then we get 4x equals negative 1. So at that point there, x equals negative a quarter. Okay, so that means that our curve there is at negative a quarter, and then it goes up to 0, and that's the origin. Right, for our triangle, we need to find point C. We've already got the equation of the line from our previous question. So from memory, that was negative a half x equals y minus 1. So we do the same thing. So the point C is on the x-axis, so that means y is 0. So if I substitute in y is 0, like that, and then I need to solve for x. So I'm going to divide both sides by negative a half, which means I get that x equals 2. That means our triangle, when we integrate it, is going to go from 0 to 2. Okay, so let me just move this up a little bit. Actually, if you wanted to work out the area of the triangle just using half base times height, you can do that. You know that the height of the triangle is 1 because that's where the point was that we found out before. It was y equals 1 on the y-axis. So you can do that as well. It's completely up to you. Or you can integrate under the line. Either way, will be fine. So if I work out the area under the curve part on the left, I'm going to be integrating between 0 and negative a quarter, and I'm going to be integrating, I'm going to write this out with a fractional power, right? So 1 plus 4x to the power of a half. So when I integrate that, I still keep my limits between 0 and negative a quarter, and then I'm going to add a power divided by that power first of all. So if I add a power, I get 3 over 2. And if I divide by 3 over 2, that's the same as multiplying by 2/3. And then I have to be careful because this is a composite function. So I need to look at this and say, well, if I differentiate this, I'd get 4. So I've got to divide through by 4 to cancel that out. So I kind of ran out of space. I'm going to squeeze a little quarter in there. Okay, so if I tidy that up, it would be 2 over 12, so 1/6. 1 plus 4x to the power of 3 over 2, all between 0 and 1/4. Okay, so when I evaluate that out, I'm going to work out what it comes out to be if I put 0 in for x, and then what it comes out to be if I put in negative quarter for x. So when I substitute in 0 for x, I get 1 inside the bracket. 1 to the power of 3 over 2 is just 1, so I'm just going to get 1/6. When I substitute in negative a quarter into here, I get 4 times negative a quarter, which is negative 1. And then 1 plus negative 1 is 0, so this whole thing becomes 0. So I'm not actually taking anything away from it. Cool, so for the triangle, if you want to do half base times height, you could. So the area of the triangle here equals half times base. The base is 2 and the height is 1, daisy, times 1. So you would just get an area of 1. Or if you really wanted to, because you love doing calculus, you could integrate between 2 and 0 the equation of the line. So you have to rearrange this into y equals mx plus c y equals mx plus c form first. So it would be negative a half x plus 1, and you would integrate that. So it would become x to the power of 2 negative plus x, all between 2 and 0. And then what you would get is the same answer. So when you substitute in 0, you get 0, but when you substitute in 2 into that equation, you get... Oh, I just realised that I slightly mucked up my integration. So back here, when you add a power, you divide through by power. So actually that becomes negative a quarter. I just realised that when I was looking at it, and I was trying to substitute in 2 and I wasn't getting an answer of 1. So, oh, what's going on? So it's good to check these things. Anyway, so when I substitute in for 2, I end up with 1 as my answer. Cool, so now we have the area of the triangle being 1 and the area under the curve as being 1/6. So the total area is just going to be adding those two numbers together. So 1 plus 1/6, which equals 7/6.